So I've got this equation, and I know, caution, this is not what it looks like. I know that if I graph this equation, it should be somewhat parabolic. And I know that all parabolas will have x-intercepts or y-intercepts. I mean, sometimes parabolas can have no x-intercepts, like this. And sometimes parabolas can have just one x-intercept, like that. But they'll always have a y-intercept. I know it's tempting to think that maybe like if we drew it way far over here, that it would never cross the y-axis. But the thing is, this is going to keep going left, 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 left. And if you give it infinite amount of time, yeah, it's going to get all the way over that y-intercept, no matter how far you place it away. That's because the domain of parabolas is infinite on both sides. So I'm just going to erase all these except for my initial one. I don't want to come up with a whole big graph to find my x-intercept. Sometimes it's important to find those things. And we're in a rush and we don't want to take all the time to graph it. I'm just going to make fake values here and see if you can spot a pattern. Both these x-intercepts, let's say that happens at 2, 0. And this one happens at, let's say, -5, 0. And my y-intercept's at 0, -10. Right? These are all fake numbers. But you can see that zeros are very important when it comes to x-intercepts and y-intercepts. In fact, the y-intercept, our strategy, we're going to plug in 0 for x. That's our strategy to find the y-intercept. Our x-intercept is going to be really similar. We're going to plug in 0 for y. The reason why this is our strategy is look at our y-intercept right here. Right? Our y-intercept, x equals 0, right? Well, I'm going to plug in 0 for x and find it. My x-intercepts, this is our y value in both cases, 0. So I'm going to plug in a 0 for x. So I'm going to just take you through how that goes. So here's my equation. I'm going to start with the y-intercept. It's the easier of the two to find. I said my strategy is plug in 0 for x. So I'm going to go y equals 0 squared minus 6 times 0 minus 7. The reason why this y-intercept is kind of nice is because when I evaluate this thing, 0 squared is 0. -6 times 0 is 0 minus 7. So y equals -7. So I know my y-intercept. I plugged in a 0 and got out a -7. So if I was keeping track on a graph, maybe I'll do that up down here. 0, -7 is like right there. It's my y-intercept. Now I'm going to find my x-intercepts. My x-intercepts, I'm going to set y equal to 0. And I'm going to get x squared minus 6x minus 7. Now, we've never solved an equation like this before. The hint on this one is we've got to factor. If we're trying to solve with, and we've got an x squared term, factoring is going to be a great method for us. It's not going to work all the time. We'll learn a way that a little bit later on that's a little bit more powerful. It takes a little bit more time, but that will work all the time. This one won't work all the time. It only works if this is factorable. And this is factorable, so we can use it. So you may remember, like, we need things that multiply -7 add up to -6. -7 and +1 are those numbers. They'll both multiply -7 and add up to -6. So I have 0 equals, if I factor this, x minus 7, x plus 1. Now we talked in class about it's called the zero product, and it has this really nice property that if you multiply two things together and they equal 0, only one or two things can happen. Right? Either this thing equals 0, either x minus 7 equals 0 or x plus 1 equals 0. So we're going to get two solutions, which kind of works out because usually there's two x-intercepts, right? So I'm going to add 7 to both sides, subtract 1 from both sides. I'm just solving these two equations at the same time. And we'll have one x-intercept at 7 and one x-intercept at negative 1. So my two x-intercepts are at negative 1, 0 and at 7, 0. So if I plot those, that's it there at 7, 0, and here it is at negative 1, 0. So my parabola will look something like this. Yeah, and that's how you find the x and y intercepts, just from a graph, an equation.